Welcome to G Fun Facts Online, your go-to source for the most mind-blowing insights from the world of science. Today, we're venturing billions of years back in time to the very dawn of the cosmos. Thanks to the incredible James Webb Space Telescope, or JWST, we're witnessing how the first galaxies burst into existence and began sculpting the universe as we know it. It's like having a cosmic time machine, and what it's showing us is challenging everything we thought we knew. Before Webb, our best views of the early universe, mostly from the Hubble Space Telescope, painted a picture of fledgling galaxies, a bit clumpy, not very organized. The general idea was that galaxies formed slowly, bit by bit, over billions of years, like cosmic snowballs gradually getting bigger. But JWST, with its powerful infrared eyes, is revealing a much faster, more complex, and frankly, more surprising early universe. One of the biggest shockers? We're finding remarkably massive and well-structured galaxies far earlier than anyone predicted. We're talking about galaxies existing just a few 100 million years after the Big Bang. These aren't the tiny, primitive specks astronomers expected. Many of them are surprisingly bright and even show features like spiral arms and central bulges, things we usually associate with mature galaxies like our own Milky Way. Take, for example, a galaxy found by the JADES program, that's JWST, Advanced Deep Extragalactic Survey. This galaxy, catchily named JADES GSD 140, was around when the universe was less than 300 million years old. And yet, it's incredibly bright and chemically complex. Scientists have even found elements like oxygen in it. This means that multiple generations of stars must have already lived, died, and enriched their surroundings much faster than we previously thought. It hints that star formation in the early universe might have been super efficient. And then there are the red monsters. These are three ultra-massive galaxies, nearly as big as our Milky Way, spotted within the first billion years after the Big Bang. These giants seem to have converted a huge chunk of their gas into stars, much more than typical early galaxies. This discovery is seriously making astronomers scratch their heads as it challenges the standard cosmological model, known as lambda CDM, which predicts a much slower buildup of these giant structures. Some researchers are even wondering if we might need to rethink our understanding of gravity or the role of dark matter in the early universe. This leads us to the too bright, too massive puzzle. A lot of these early galaxies are just brighter and heavier than our models say they should be. Now, some of the initial panic about a cosmic crisis has calmed down a bit. It turns out that supermassive black holes at the centers of these galaxies can make them look brighter and larger. But even with that accounted for, there's still a tension. We're still seeing more massive galaxies in Webb's data than our theories predict. What could this mean? Well, one idea is that star formation was simply way more efficient back then. The conditions in the primordial universe, denser gas clouds, perhaps different feedback effects from the very first stars and black holes, might have turbocharged star birth. Webb has even spotted star bars, those elongated regions packed with new stars, usually seen in mature spiral galaxies, in galaxies that existed only a few billion years after the Big Bang. This suggests that galaxies might have settled into organized structures much quicker than we anticipated. Webb is also giving us incredible new views of the cosmic dark ages. This is the period after the Big Bang, before any stars or galaxies had formed to light up the universe. It's followed by the epoch of reionization, when this first light started to burn through the neutral hydrogen fog that filled all of space. Observations of galaxies like JADES GSZ 13-1, seen just 330 million years after the Big Bang, show surprisingly strong Lyman alpha emission from hydrogen. This is a big deal because at this early stage, that neutral hydrogen fog should have absorbed this light. The fact that the light escaped suggests these early galaxies were powerful enough to carve out bubbles of ionized gas around themselves. They were playing a key role in clearing that cosmic fog and reionizing the entire universe. How they did it Maybe through populations of extremely hot, massive first-generation stars, or powerful active galactic nuclei fueled by early supermassive black holes, is still a hot topic of research. And speaking of supermassive black holes, their relationship with their host galaxies is another cosmic chicken-or-egg riddle that Webb is helping us unravel. Did the black holes form first and then gather galaxies around them? Or did galaxies form first and then nurture these behemoths at their centers? Webb's observations are throwing in some fascinating clues. It's finding supermassive black holes in the early universe that appear overmassive for their host galaxies. This means the black hole is significantly larger relative to its galaxy stars, compared to what we see in galaxies closer to us today. Some of these early black holes have been found to equal the combined mass of all the stars in their entire host galaxy. That's astonishing. Webb has also detected the most distant black hole merger ever observed in a system called ZS7, when the universe was only 740 million years old. And it might have found the oldest known black hole in the galaxy GNZ11, dating back to just 400 million years after the Big Bang. And this black hole is already incredibly massive. These discoveries suggest that supermassive black holes could grow extremely rapidly in the early universe, perhaps even growing alongside, or even before, their host galaxies were fully formed. Some theories even propose these early, massive black holes could have sped up star formation in their vicinity. Beyond just their size and age, Webb is also revealing the chemical makeup and structure of these ancient galaxies in stunning detail. Data from Webb's Near-Infrared Spectrometer, or NIR SPEC, has shown unusual chemical properties in early galaxies. We're seeing higher than expected concentrations of elements like nitrogen, helium, neon, and carbon compared to our Sun. These findings are helping us refine our understanding of how stars create elements and how the chemical composition of the universe has evolved over time. Structurally, Webb has found that many distant galaxies exhibit flattened oval disk shapes, or even tube-like structures, rather than the distinct spiral or elliptical shapes we're used to seeing in the nearby universe. This is prompting more research into how galaxies change their shapes over cosmic history. And then there's Zhulong, an ultramassive grand design spiral galaxy with beautifully defined spiral arms and a central bulge, existing just 1 billion years after the Big Bang. A galaxy like that, so early on, really challenges the idea that such organized structures took much longer to form. Webb is constantly pushing the frontiers. Scientists are now identifying candidate galaxies from as early as 200 million years after the Big Bang. These still need to be confirmed with more detailed observations, but they hint at the very first clusters of stars to emerge from the primordial soup. The flood of data from the James Webb Space Telescope is undeniably reshaping our understanding of how early galaxies evolved. It's an incredibly dynamic and exciting time in astronomy. Scientists are working hard to fit these new, sometimes puzzling observations into a more complete picture of how our universe came to be. The surprises from Webb aren't necessarily breaking cosmology, but they are definitely enriching it. They're forcing theorists to refine their models and explore new possibilities about the physics that governed the dawn of galaxies. So as Webb continues its mission, peering deeper into the cosmic past, we can only anticipate even more profound insights into our cosmic origins. The universe's baby pictures are turning out to be far more fascinating and complex than we ever imagined. That's all for this episode of G Fun Facts Online. Thanks for tuning in as we explored the revolutionary discoveries of the James Webb Space Telescope. Join us next time for more amazing facts from the universe around us.